Now we will solve problems regarding homogeneous differential equations. The first problem says x cube plus thrice x y square dx plus y cube plus thrice x square y dy equals to 0. Now first we will take dy dx at one corner, at one side. So we will write this equation as x cube plus thrice x y square dx equals to minus y cube thrice x square y dy. So dy dx should be minus x cube plus thrice x y square by y cube plus thrice x square y. Now here every term, here x cube degree is 3, xy square degree is 3, so every term's degree is 3. So this is homogeneous function at numerator and homogeneous function at denominator. So when homogeneous functions are there, we will express it by function of y by x. So we will divide numerator and denominator with x cube. So we will get y by x whole cube plus 3y by x. Okay, so this form is with respect to y by x, is a function of y by x. Now let's take y by x equals to v. So y equals to vx, dy dx equals to v plus x dv dx. Now in this equation we will replace this information. Okay, so the star equation becomes dy dx should be v plus x dv dx equals to minus 1 plus 3 y by x should be v, so v square over v cube plus thrice v. Okay, now v plus 1 plus thrice v square by v cube plus thrice v equals to minus x dv dx. Okay, v cube plus thrice v as LCM. Now we get v4 plus thrice v square plus 1 plus thrice v square. Okay, equals to minus x dv dx. v4 plus 6v square plus 1 by v cube plus thrice v equals to minus x dv dx. Okay, now we get dx by x equals to minus v cube plus thrice v by v4 plus 6v square plus 1 dv. Now we will integrate on both the sides. Now we will integrate. Integrating on both the side, v cube plus thrice v by v4 6v square plus 1 dv. Here the integral is ln x or natural logarithm of x, but here we will set the numerator with respect to the derivative of denominator. The derivative of the denominator is 4v cube plus 12v, and now we should balance this for forming v cube plus 3v. So we should balance by multiplying 1 by 4. If we take 1 by 4, then it is v cube and it is thrice v. Okay, v4 plus 6v square plus 1 with respect to v. Now this integral should be natural logarithm of x equals to minus 1 by 4. This integral will be, here the numerator is directly the derivative of denominator. So we will get natural logarithm or ln v4 plus 6v square plus 1, okay, plus some constant. Now 1 by 4 we will multiply by 4 and 1 by 4 will be vanished. 4 ln x equals to minus ln b4 plus 6v square plus 1, and then plus 4c will be another constant. We will write it as k. Now ln this 4 will be exponent of x, ln x to the power 4 plus ln b4 plus 6v square plus 1 equals to k. Okay, now here we can modify it as ln x to the power 4 times v4 plus 6v square plus 1 equals to constant. So x to the power 4, v was y by x. We took y by x as v, so we will write y by x as v. Okay, x to the power 4 times v4 plus 6v square plus 1 equals to ln means log e base, and we will get e to the power k. E to the power k should be a newer constant. So x to the power 4 y4 x4 6y square x square 1 equals to a newer constant c. Now we will multiply with x to the power 4. We will get y to the power 4 plus 6y square x square plus x4 equals to c. Okay, this is the solution. Now we are going to the problem 2. This problem says y square plus x square divided dx equals to xy divided dx. We will first separate dy dx as an entity to left hand side or to a right hand side. Okay, so dy dx, we will take dy dx as in left hand side. So dy dx xy minus x square equals to y square. So we kept dy dx at left hand side, at one side, y square by xy minus x square. Now this numerator's degree is 2, and this denominator's every term's degree is 2. So this is homogeneous function, and it is also homogeneous function. So we will put the form function of y by x. So we will divide both numerator and denominator with x square. So y square by x square over xy by x square minus x square by x square. Now we get y by x whole square, y by x minus 1 dy dx. We will call it as star equation. Now we should take y by x equals to v. So y equals to vx, dy dx should be v plus x dv dx. Now we will put this information into this star equation. Okay, so the star equation becomes dy dx as v plus x dv dx equals to y by x should be v, so v square by v minus 1. Okay, now x dv dx equals to, we get v square by v minus 1 minus v. So x dv dx equals to v square minus v square plus v by v minus 1. V square will be removed. Now we get x dv dx equals to v by v minus 1. Okay, so dx by x equals to v minus 1 by v dv. Okay, now we will integrate both the sides. We will get this side as ln x, this integral, and this integral is 1 minus 1 by v integration with respect to x. So sorry, with respect to v, in fact that is dv. So ln x equals to integration of 1 with respect to v is v minus integration of 1 by v with respect to v is ln v plus some constant. So ln x plus ln v equals to v plus c. Ln x into v equals to v plus c. We took v as y by x, so we will replace v as y by x. Okay, so this x is removed. Ln y equals to y by x plus c. Ln y means log e base y. Y equals to e to the power y by x plus c. So y equals to e to the power y by x into e to the power c. E to the power c should be a newer constant, so we can write y equals to e to the power y by x into newer constant k. So we get y equals to constant e to the power y upon x. So this is the solution. Okay. Now we are going to the third problem. This third problem is x square minus y square dy equals to twice xy dx. We will take dy dx separately at one side of the equation. So we will take dy dx at left hand side equals to twice xy by x square minus y square. Okay, now this numerator is a function and it is homogeneous, and the denominator is also homogeneous. So we can express this fraction, we can express this fraction by function of y by x. So we will divide both numerator and denominator with x square. So 2xy by x square by x square minus y square by x square. Okay, now we get 2y by x, 1 minus y by x whole square. So this function is expressed as f of y by x. When we can recognize a fraction as a homogeneous function? The answer is when the fraction will be expressed as function of y by x, So here is every term y by x. So this is function of y by x. Now let's take y by x as v. So y equals to vx and dy dx equals to v plus x dv dx. Now we will call this equation as star equation. We will replace this information into this star equation. So the star equation becomes dy dx as v plus x dv dx equals to 2 y by x should be v by 1 minus v square. Okay, now x dv dx equals to twice v by 1 minus v square minus v. X dv dx equals to twice v minus 1 plus v square. In fact, twice v minus v plus v cube by 1 minus v square. So x dv dx equals to v plus v cube by 1 minus v square. Okay, now we will get dx by x equals to 1 minus v square by v plus v cube dv. Okay, now we get dx by x equals to 1 minus v square by v plus v cube dv. Will integrate both the side. Okay, will integrate both the side. Now we'll integrate this part by partial fraction method. This fraction is proper fraction, so we will call this equation as double star equation. So we will take 1 minus v square by v plus v cube equals to 1 minus v square by v into 1 plus v square. We will assume it as a by v plus 1 plus v square, and the numerator should be bv plus d. Okay, now we will find the value of a, b and d. Okay, we will multiply with v into 1 plus v square. We get 1 minus v square, a 1 plus v square plus bv plus d into v. Since it's an identity, so we can take any value of v. So we take 0 as v, we get 1 equals to a plus 0. So we get a equals to 1. Okay, now we take v as 1. If v equals to 1, then 0 equals to a into 2 plus b plus d. Okay, here a is 1, so we get 0 equals to 2 plus b plus d, so b plus d equals to minus 2. If v equals to minus 1, then we get 1 minus 1, 0, 0 equals to 1 plus 1, 2, a is 1, so 1 into 2 plus minus 1 into b minus b plus d into minus 1. So we get 0 equals to 2 plus b minus d. Okay, so we will get b minus d equals to minus 2. B minus d equals to minus 2. Okay, now if we add these equations, we will get 2b equals to minus 4. So b equals to 2b equals to minus 4. So b equals to minus 2. Okay, and if we subtract b minus d from b plus d, then we will get 2d equals to 0, so d equal to 0. So we got the value of a, b and d, and now at last we can write these equation as 1 minus v square v 1 plus v square equals to a was 1 and b minus 2 d 0 1 plus v square. Okay, so we will get 1 by v minus 2v by 1 plus v square. Now we will replace this information into the double star equation. Okay, now the double star equation becomes integration dx by x equals to integration 1 by v minus 2v by 1 plus v whole square with respect to v. This part we will get ln x equals to ln v, and this part 2v is the direct derivative of this denominator. So we will get minus ln 1 plus v square, okay, plus c. Now ln x minus ln v plus ln 1 plus v square equal to c. Now ln, we can write x by v into 1 plus v square equals to c. So x by v 1 plus v square equals to e to the power c. E to the power c should be a newer constant, so we get x by v 1 plus v square equals to newer constant. Okay, now we get x by, we took v as y by x, so we will replace y by x into 1 plus y by x whole square, okay, equals to constant x square by y, 1 plus y square by x square equals to constant. So we will get x square by y, x square plus y square by x square equals to constant. So x square is removed, we get x square plus y square equals to ky. So this is the solution of this differential equation. Now we will solve the fourth problem. The fourth problem says x dy dx plus y square by x equals to y. First, we will separate dy dx as an entity as in the left hand side or at the right hand side. We will take here dy dx at left hand side. So dy dx equals to y minus y square by x over x. Okay, now we get dy dx equals to y by x minus y square by x square, and this function is completely function of y by x, so of course it is homogeneous. Now we will take y by x as v, so y equals to vx, dy dx equals to v plus x dv dx. Now we call this equation a star equation. We will replace this information into this star equation. The star equation becomes dy dx should be v plus x dv dx equals to y by x should be v minus v square. Okay, now we can write this v is gone, x dv dx equals to minus v square, so dx by x equals to minus 1 by v square dv. Okay, integrating both the side with respect to x, now you will get ln x equals to minus b to the minus 2 plus 1 by minus 2 plus 1 plus some constant. Okay, now from here we get ln x equals to this minus 1 and this minus will be multiplied and we get plus v to the minus 2 plus 1 is minus 1 plus c, so ln x equals to 1 by v plus c ln x. We took v as y by x, so we will write v as y by x, so we get ln x equals to x by y plus c. Okay, so this is the equation, this is the solution. Okay, we can still modify it. Ln x we can write log e base x equals to x by y plus c. Now x equals to e to the power x by y plus c, so x equals to e to the power x by y into e to the power c. E to the power c should be a newer constant, so we can write k, so we can get x equals to k e to the power x by y. So this is the modified solution of this differential equation. Now we will go to the problem 5. Here the problem says x times x minus y dy plus y square dx equal to 0. We will take dy dx as an entity at the left hand side or the right hand side, but here we will take at left hand side. So we will get x minus y dy equals to minus y square dx, so dy dx, here we keep dy dx as in left hand side, so dy dx equals to minus y square by x square minus xy, so we get dy dx equals to y square by xy minus x square. Okay, now this numerator is homogeneous function and this denominator is also homogeneous, so this can be written as function of y by x. Okay, so we will divide both numerator and the denominator by x square, so y by x whole square will divide numerator by x square, and we'll divide denominator with x square. We get y by x minus 1. Okay, now let's take y by x should be v, y by x should be v, y by x, and then y equals to vx, dy dx equals to v plus x dv dx. Putting this information into this star equation, we will get dy dx as v plus x dv dx, v plus x dv dx equals to y by x as v, okay. Now x dv dx equals to v square by v minus 1 minus v. So x dv dx will be v minus 1 v square minus v square plus 1. In fact, not plus 1, plus v, okay. So v square will be removed, x dv dx equals to v by v minus 1. So dx by x equals to v minus 1 by v dv, okay. Now we get from this equation dx by x 1 by v minus, in fact 1 minus 1 by v dv, and we will integrate both the side, okay. Now we get ln x equals to v minus ln v plus c. So ln x, we took v as y by x, ln y by x plus c, ln x plus ln y by x equals to y by x plus c. So ln x into y by x equals to y by x plus c, okay. Here x is removed. We get ln y equals to y by x plus c. ln y means log e base. Now we can write y equals to e to the power y by x plus c, e to the power y by x, e to the power y by x into e to the power c. E to the power c should be newer constant, so we get e to the power y by x into k. So the solution is y equals to constant e to the power y by x. So this is the solution, okay.